In this video, we're going to be looking at compound growth and decay, also known as compound interest and depreciation. So let's say we invest £20,000 and we receive 5% interest per annum, per year. For some reason, they use this Latin version of the per year, and we're going to do that for 3 years. Okay. And essentially what's happening is when you invest this £20,000, the bank or the institution will give you 5% each year and you will receive that money. So for the first year, if we do 20,000 times 5%, that's £1,000. So 5% will be equal to £1,000. And then we add that onto our total, 21,000. This is year 1. Okay, and then essentially we just repeat the same process for each year that we're investing for, but we change our initial value to 21,000 now. So we work out 5% again of £21,000, and you'll see that the interest goes up slightly, 1,050, and we can add that on to our 21,000, £22,050. And we just keep repeating that process for the 3rd year, for the 4th year, etc. Okay. If this was a decay question or a depreciation, like a car reducing in value, then instead of adding it on each time, we would just subtract it. So it would be 19,000, and then we would work out 5% of that and take that off and keep repeating the process. Now there is a more efficient way of doing this. We can speed things up and also prepare for the higher level questions. If we do 20,000 times 105%, we don't have to worry about multipliers and decimals and everything like that. This is the same as working out 5% and adding it on. And then we can take our last answer and times 105% again. There's our 2nd year. If I press equals again, there's a 3rd year, 4th year, and so on. So this is a bit of an improvement on our speed for this. We did 20,000 times 105%. Okay, and if this was decay, we would do 100 minus 5%, so 95% each time. You may have noticed that we just multiplied by 105% each time when we did that last answer times 105%. So the ultimate version of this would be the power here is the number of years. So 20,000 times 105%, and we raise the percentage to the power of the number of years, and we get the answer straight away.